As with all testing, the concept of coverage is key. Coverage is a metric for how thorough your testing is. Getting high coverage can be difficult. Think of it as trying to paint a wall. Painting the wide open middle, pretty straightforward, takes a few roller strokes. Getting into the nooks and crannies in the corners, that's a little bit more delicate work, takes more time, takes more attention. Coverage metrics tend to reflect this. The simplest, coarsest metric for unit testing is function coverage. How many functions in your system did you test at all? If you never even tried to test half the functions, well, that's probably not very thorough testing, is it? Once you've gotten to the point where most or all of the functions have been tested at least a little, a finer-grained notion of coverage is statement coverage. What fraction of the code statements have been tested? Did you actually execute every line of code at least once? A typical metric here might be that you've tested 95% of the lines of code. Well, 95% sounds good, but that means 5% of the codes in your system have never been executed at all. And depending on your system, that could be a problem. Once you've executed all the lines of code, there are still better types of coverage metrics available. The next one is branch coverage, also called path coverage. In branch coverage, you say, all right, I've executed all the lines of code, but did I try each branch both ways? This one's a little subtle. If you have an if-else statement, then 100% statement coverage means you also got 100% branch coverage because you must have done both the if and the else. But branch coverage also includes the notion that if you have an if without an else, did you do both the if and did you also do the if being false, which skips the code? If you missed the skipping the code, you still might have 100% statement coverage, but you'd be missing that half of the branch coverage for that if statement. An even finer-grained notion of control flow coverage is MC/DC coverage, which we'll handle in the next slide. Getting to 100% coverage can be a bit tricky. If you have error handlers for errors that are never supposed to happen, you can't get 100% coverage unless you make that error happen. Now you might say, well, it's never supposed to happen, so what's the big deal? Well, the counter to that is, if you have an error handler that you've never actually tested, how do you know it's going to work if that error actually occurs? You need to find some test method to exercise the handler to make sure it really works. Another issue with 100% code coverage is dead or unused code. And usually there, what you should be doing is, if that code cannot ever be executed, why is it there? Probably you should take it out.